Okay, so what we're going to do today is we are going to factor the difference of two squares. We happen to call this thing dots, and that just stands for difference of two squares. When we talk about squares, I'm talking about perfect squares. If we started to count by perfect squares, let me just kind of throw this in here real fast. Perfect squares would be things like this. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. If we go all the way to 100, 49, 64, 7, 8, 9, 81, 100. All of these things are perfect squares. So you're going to see one, if not two, of these numbers in your problem when we do the difference of two squares. Let's get back to this first notes page. So recall that if you were to FOIL two binomials where you had the exact same things in both parentheses, but one was minus and one was plus, that ended up being a squared minus b squared. That's what happens when you FOIL. So it happens to be a special pattern called the difference of two squares, and when we do this with reverse distribution, or when we factor a squared minus b squared, you're going to end up with the two parentheses of a minus b, a plus b. Probably not following that part. Don't worry about it. Take a look at this. If we wanted to I am something like number 1, the problem with IMing number 1 is trinomials are always in the form x squared plus bx plus c. But if you look at 1, you've got x squared, but there are no x's. There is no middle term. And then your c happens to be a negative 25. Well, if you do I am like you normally would here, I am, and you look for two numbers that are going to add to 0 but multiply to negative 25, you're looking for two numbers with different signs that are inverses of one another. Because the only way to add to 0 is to have one number be positive and the exact same number be negative. So what number multiplies to 25? Or what's the square root of 25? And that would be 5 times 5. So when you wanted to factor this, you'd have to have an x with a positive 5 and an x with a negative 5. Because again, the only way to be able to multiply to a negative is to have both signs different. And the only way to add to 0 or add to nothing is to have those exact same numbers. So it kind of follows the pattern what I was saying about up top. If you've got the difference of two squares, two perfect squares being subtracted, your answer is going to be the square root of each of those perfect squares. In one parenthesis you have a minus, in one parenthesis you have a plus. So in this case, x squared minus 25 is x plus 5, x minus 5. The parentheses can be reversed, having the x minus 5 first and the x plus 5 second. It doesn't really matter. So take a look at number 2. You have a subtraction problem. You have a difference. Do you have a difference of two perfect squares? And you do, because 100 is a perfect square, and so is 36. And any variable that's got an even exponent is also a perfect square. So if we try to follow this pattern up here, then what we do is we give ourselves two parentheses, and we say, well, what is 100x squared broken evenly, or the square root of it? And it becomes 10x and 10x. There's 100x squared. What's the 36y squared broken evenly? Well, that would be 6 times 6, or 6y times 6y. What happens is because it multiplies to a negative, the signs have to be different. And there's your final answer. These are probably the easiest types of factorings that you'll do, is the difference of two squares, assuming you can recognize that that's what it is. Let me extend this page up a little bit. The next one, do we have a difference of two squares? And we absolutely do. Subtraction sign, and both of those values are perfect squares. So you give yourself two parentheses, and you say, well, 81 becomes 9 times 9. 16x squared becomes 4x and 4x, and the signs have to be different because that's the only way to get a negative 16x squared. When you look at the next one, again, two terms, subtraction sign, both being perfect squares. Remember, any even exponent is a perfect square because you just divide it in half. So what's going to happen here is I'm going to get a squared minus 2b and a squared plus 2b. And that's going to give you your difference of two squares answer. Again, what we haven't done is show you to check in some of these, and we can always check our answers by FOIL. Let's check this one by FOIL. If you do a squared times a squared, a to the fourth. A squared times 2b is 2 a squared b. Inside, it's negative 2b times a squared, negative 2a squared b. Last times last, negative 4b squared. Well, what happens is these guys right here are inverses. They go away, which means you check into the final answer of a to the fourth minus 4b squared, and that was what the original problem started out to be. Okay, so there's your beginning of your dots. What you can do now, though, is then you should be able to factor completely. Kind of like what we did yesterday. Let me get back out of this page. Let me go to the next page. Kind of like what we did yesterday when it was factor completely. Here what's happening is, again, because of completely, you're always going to look to see if there's a GCF first. Then you're going to look to factor again. I know that these are going to be factored again by dots because I happen to be in the dot section, but eventually we'll mix them all up. So the first one on number 5, is there a GCF? And there definitely is. The GCF is 3 outside a parenthesis, which is what's left over being x squared minus 16. Well, what's in parentheses is a perfect square. It's a dots problem. I'm going to carry down my GCF. I'm going to open up the parentheses, and now I'm going to have x minus 4, x plus 4, and my GCF. Same thing's going to happen on the next one. What's the GCF between this one? Between 12 and 27, you're looking to have a GCF of a 3. Again, a 3. What's left over? 4x squared minus 9y squared. Well, inside that parenthesis is also a dots problem. So my 3 can't go away. Open up my two parentheses. 2x, 2x, 3y, 3y, 1 plus, 1 minus, and you are done. Okay, so that should be good to get you on to the next homework.